Right, what you see on the screen is kind of our intro to our 3.5 section. We are going to talk about ordering relations. So we're talking about two quantities that you want to compare and decide which one's bigger. So that's what ordering means. Or which one's even smaller. It doesn't have to be bigger. And then order of operations at Please Excuse My Dear Aunt Sally. So PEMDAS. We've talked about that before, but that's going to come up today using all of our fraction rules, which I'm sure you love. So I want you to see that on a number line, and that's what you see here. I want you to compare the numbers 1 and 2, right? They're whole numbers. And I want you to realize that anything that is on the far right side of a number line is bigger, right? So the 2 is on the right side of this other number that I'm comparing, and so 2 is bigger. Anything that is on the left side when you're comparing two items is smaller, and so we need to keep that in mind. So looking at this number line, I want to compare the two numbers 1/2 and 4/3. Okay, to do that, I'm going to kind of move the red out of here that I've already written because I don't want it to like confuse you or anything. So in between these, I'm going to have a box. And we put in this box one of these symbols. And so this is greater than, less than, or even equal to. So the way that we remember that this is greater, or this one is less than, the way I remember is that this guy kind of looks like an L for me to write less. That's how I keep that in my mind. So when I put one of these symbols in this black box here, trying to decide which one's bigger, how do I do that? Well, I multiply in the diagonals. If the denominator's already matched, you could just look at the top numbers and whichever one is bigger is the answer. Most of the time when they give these to you, the denominators will not match. So in this case, 2 and 3 do not match. So I'm going to multiply in the diagonal here and get 8. Multiply in the diagonal here and get 3. So I'm comparing 3 and 8. Which one's bigger? The 8, and so we get this symbol. How do I know that that symbol goes there when I read it? 3 is less than 8, right? Because less than is a symbol right here. Or from our elementary school days when I drew the little teeth in here and the eyeball, and the mouth eats that bigger number. See that mouth right there? It's going to eat that bigger number, which is 8. If I didn't know those tricks, if I was looking back at my number line, here's my 1/2 and here's my 4/3. I told you that anything on the far right side is bigger, and so we would know right then that that symbol goes that direction. Okay, let's try another one. So 9/4 and 1. Well, if I'm talking about a number line, here's 1, and 9/4 is clearly somewhere down here because it's bigger than 1. So anything that's on the left or far right side is bigger. How did I know that this was on this side of the 1? Because the top number is bigger, which means it's bigger than 1 whole. So we knew that this was bigger, and so the mouth goes that way. The other way we can do this is to know that this is 1/1 as a fraction. And so 4 times 1 is 4, and 1 times 9 is 9, and so I know that this side is bigger because 9 is bigger than 4. Okay? All right, we're going to move into PEMDAS. So that Please Excuse My Dear, sorry, Aunt Sally is add, subtract. So this is parentheses. And then exponents. So these are my rules. I'm going to have this first problem that looks like this. I have 1/3 plus 1/2 times 4/5. I'm going to start with parentheses, and I can't do anything inside those parentheses because I only have one fraction, one number in there. Exponents, I don't have any, so I'm at this multiply stage, right? Multiply these two together. And so I will multiply 1/2 and 4/5. They don't need a common denominator. You will just multiply across the top and across the bottom and then simplify if you can. So I'm going to simplify first. Remember that was an option, dividing by 2. So I get 2 here and 1 here. Multiply across the top and I get 1 times 2. Across the bottom and I get 1 times 5. So this became 2/5, this whole part. What have I not used? The plus 1/3. At this point, I'm adding, and remember, for adding and subtracting, I need a common denominator, so I need to multiply my denominators to get 15, bring down my plus sign, multiply the diagonal and get 6, and the other diagonal and get 5, and so now I'm adding across the top to get my new answer, my final answer, I guess. And so 6 and 5 give me 11 over 15, and this is my final answer because it cannot simplify. Let's move on, try another one. 3/8 times 1/2 plus 1/3. So I start with parentheses because that's the part for please excuse my dear Aunt Sally. The P starts first, so parentheses. I do not have common denominator. I need one because I'm adding or subtracting, right? So 2 times 3 is 6. Multiply the diagonal and get 2, multiply the diagonal and get 3. I add these together and I get 5 over 6, so this whole part became 5/6. I leave it in parentheses because notice right here that there's no add or subtract between them, so it means that it's touching, which means that this answer is multiplied times 3/8. I can take away the parentheses and write it with a dot if I'd like to, but I have to remember that it's multiplication. I'm going to divide by 3 in both of these diagonals here and get 2 and 1. I'm going to multiply across the top, and that's 1 times 5. Across the bottom, that's 8 times 2. And so I end up with 5/16 as my final answer.